So, should we get started?
Yes, sir.
Okay. So, I know some of you are probably hungry, so I don't want to delay this too much. Okay. So, the next item we'll talk about is ACI 440.1R. Okay. So, let's try to recap what we have done so far. What we did first was we tried to understand what composites are. Then we said what kind of applications we can use or what kind of applications are suitable for FRP. Then we talked about the material properties, right? Properties of composites, properties of fibers, properties of resins and or matrix. So that's what we did. Then we tried to understand the making of the fiber, glass fiber. That's what we did today. Then we looked at how to fabricate fibers. So those are all the things that are very useful. But at the same time, we are mainly here to do the structural design, right? That's the main focus of our workshop. So then we looked at processes and then micromechanics. So that's where we are at. So if you are going to use a new product, you will always ask for mechanical properties from the supplier, and they will probably give you, I'll define what it is, they will give you guaranteed strengths, guaranteed properties. Okay? So anytime you are using new material in practice, it becomes very tricky because there are no guidelines for your design. So what do? So ACI helps us in that respect. They created this document. ACI Committee 440 deals with FRP materials. It has state-of-the-art report, then internal bars, then external reinforcement, and then they have test methods, pre-stress concrete. There are so many different kinds of documents. If your library can get those documents for you, that would be very good. It's kind of expensive, but that's what it is. So if you can charge it to your project or something, that would be good. Or your library can get it for you. So all the guidance is given in here. That way I don't have to take responsibility myself, but I can always use this as my basis for design. So I'll try to, thanks, you can give it. So I'll introduce you to the guidelines of ACI 440.1. That's what I'll be doing today. I also intended, or in my schedule, I had this one more chapter, but I don't know if we can finish that today. So at least we'll go through these FRP guidelines and the scope of the guidelines. That's what I'm going to do today. Okay. So ACI 440.1R. You're welcome to come and see this here if you want. I'm unable to give you a copy of this because it has my name on this, so I don't want copyright violation with my name on that. So that's the reason I cannot give you a copy of that. So it gives you 440.1R gives you guidance on design and construction of FRP bars, and it tells you clearly not to consider using FRP reinforcement only if it is suitable and or necessary. Okay? It doesn't tell you replace your steel bars everywhere. It will not work. It will not be economical to completely substitute steel reinforcing bars in your day-to-day structures. That was the first question in our quiz number 1. That's the reason I'm trying to highlight that FRP is not an automatic replacement of steel reinforcement. That's something ACI also recognizes. Okay? And then it's useful in corrosion environment. We know many of these are repetitions, so I'll just go a little bit faster. But I'll highlight some things that need to be highlighted. For example, in movement resisting frames, so rigid jointed frames, right? In your building frames, which will have rigid joints, that means the rigidity of the joint will help you carry the lateral loads. And your FRP reinforcement should not be used in the rigid jointed frames. Okay, it's not recommended. And also, if you are considering, how many of you use moment redistribution in your design? A few of you, that's good. So, what kind of moment redistribution do you use? How much maximum? 30%. Wow, you are following British standard, right? That's the reason. Yeah? Yeah, that's right. So 30% is a lot, right? Anyway, ACI doesn't allow 30%. But 30% is a lot, but main thing is you have to detail for the rotation of the ends. That's the main thing. Is that right? So additional detailing is required to create the plastic hinge. And that cannot be done with FRP. Plastic hinges cannot be formed with FRP reinforcing bars. And therefore you cannot use FRP bars in rigid jointed frames with moment redistribution. I am really not surprised, but it's interesting that many of you are using 30% redistribution. It's really nice. But for steel reinforcing bars, 30% will work, no problem. At least 30% is allowed. European codes are all using 30% as maximum. ACI doesn't allow 30%. Okay, so FRP is a no for moment redistribution. Now, do not rely on FRP bars to resist compression. We talked about it many times. And for beam columns, we also clarified that FRP bars falling in the compression region cannot be considered for contribution to the equilibrium equations. Okay, now the crushing strain of concrete, there is small differences between ACI requirements, American Concrete Institute 318, and what we have in IS 456. IS 456, I don't know if you are familiar with this, but IS 456 came out for the first time in 1982. 1982. Many of you are probably not born at that time, right? 82 or 81. 82, I think. They revised it only once, in 2000. They are sending out amendments but not revising. I don't know why. But anyway, and most of the IS 456 provisions are from either British Standard or Eurocode, right? ACI and Eurocode or British Standards are different in many ways. So I need to highlight, I'm hoping or expecting that some of you, because I have been talking with many of you, actually out of the 60, I probably talked with more than 25 already. Some of you are already designing or wanting to design with ACI 440. So what I will do is I'll highlight the differences. Very important for you to know the differences. You cannot actually pick up this, find out the moment strength here and apply your IS 456 loading and say it will work. It will not have the same amount of safety factors or safety included in the design because the basis for design is somewhat different. Like the basis for design by ACI is different from the basis for design in your British Standards and Eurocode. And I didn't know this, so I asked one of our colleagues here, I asked, are we still using cubes or cylinders? And I hear you are using only cubes still, right? So cube strength is equal to how much of cylinder strength? 80%, right? Roughly 80%. So Right. So for the same concrete, correct. So for the same concrete, you make cubes, you make cylinders. Cylinders will show smaller strength. Very important to know that. I'll tell you why. All these are based on cylinder strength. Okay, think about it carefully. So if I have 25 anything, MPa concrete using cylinders, let's say 20 concrete in cylinders, which is a low strength by the way, 20 strength by cylinders, the corresponding cube strength will be 25. Is that correct?
Yes.
Thank you for confirming. So cube strength of 25 will give you cylinder strength of 20, right? All these provisions in ACI, if you are planning to use this, you have to make that distinction, because they are all based on cylinder strengths. So you will be safe or unsafe using cylinder strength? Huh? It can be either safe or unsafe, right? It will be unsafe by 20% to 25%. Very, very important. I just really wanted to highlight this to you, because this is all based on cylinder strength. Eurocode has already switched to cylinders. I don't know about British standards, but Eurocode has switched to cylinder strength. So if you are designing using cube strength, you already have 20% reduction in not strength, in your safety.
But we are designing over design section.
No. You are designing unsafe section.
By considering cylinder strength.
By considering cube strength. Am I right? I may be wrong. You tell me whether I am right or wrong.
Sir, actually we are designing on overside as per the IS 456.
No, you are using cube strength as the basis.
This is not the actual strength in my view. Actual strength is the cylinder strength of concrete.
Right. But what the standard says is use cube strength, right? So if you are designing based on cube strength, you are already inserting 25%, 20% of unsafe condition. That's what I'm saying. I'm trying to caution you, okay? Because without knowing that, if you just use the ACI code, it assumes that it's a higher strength concrete. But if you are complying with the code using cylinders, that means you are already introducing a 20% difference. Okay, so that's something to remember. Now, the failure strain of concrete in IS 456 is how much? 0.0035, right? Whereas ACI uses 0.003. Not that it makes a big difference, it won't, but there is a difference. You have to know that in the derivations. Do not use FRP in columns, we know that, or any as compression reinforcement in beams. If you are using doubly reinforced beams, don't use FRP as a compression reinforcement. So what they are doing is, in some of the structures, they use different types of bars at the top, and like top bar can be epoxy coated bars, bottom bars are black bars. They are doing that. That's not disallowed. So you may want to consider those things, because if you have a three-span slab bridge at the support locations, the top is in tension, right? It's bending this way. Top is in tension at the supports for continuous beams. So the top is actually exposed to larger corrosion effects. So you may have epoxy coated bars at the top. At the bottom, it's not really a problem. So they use normal black bars. That's mixed mode is possible. You may try to use that kind of approach even here if needed, because really you cannot use FRP bars in compression regions. Okay? So much of the stuff I am going to discuss is based on ACI 440.1. And the reason I am trying to bring out those differences is for you to understand that there is difference, and you can actually adjust your equations slightly to make it consistent. So we have a lot of advantages and disadvantages. We talked about this already, so I'll move on. If you want, you can read this on your own. Then, sorry. And then you have why use FRP. We know all of this mostly. There are some items we have not talked about. For example, this one here. Less concrete cover is possible. You agree or disagree? It is. You agree. Of course, this is ACI. How can I not agree, right? But remember one thing. There are always many times in order to prove that FRP is better than other steel reinforced members, the producers will put a lot of pressure on you to say, okay, use concrete cover of 1/4 inch, 0 inch, whatever. 1/4 inch is 6 millimeter, right? 6 millimeter, 10 millimeter, that's enough. Do you really think if you have a 20 millimeter bar, a 6 millimeter cover is enough? Okay, no is correct. It's not enough. 6 millimeter is not enough. Why not?
Did not transfer the tensile stress to the lattice.
The ability point of view.
Yes.
Ability point of view.
One thing, yes.
It's very easy for the moisture for ingress.
Okay, but migration is not a problem for me because FRP is supposed to be corrosion resistant. So that's the reason they are pushing for almost no cover, okay?
Fire resistance.
Fire resistance is yes, that's the problem, big problem.
Maybe a bonding problem.
Yes, that's right. You cannot develop your bond. Unless you have concrete around a bar, you really cannot develop bond. If you don't have bond, that beam will not function. So you just remember some minor things like this because there's always pressure. Others will put pressure on you to use their product. They'll say, oh, we can reduce your concrete cover to 0 inch. No. You need a minimum amount of concrete cover to actually develop the bars, and therefore it's not okay to not have cover, okay? So to the extent that, okay, let's not go there. But anyway, less concrete cover is possible, but that's not, it cannot be 0. This item is new. It says easily consumed by excavation equipment. If you are demolishing anything, you are removing some stuff. If you are already built it, you want to remove the slab, it's easy to just crush the concrete and the reinforcement without any problem. If it is FRP. If it is steel, then you have to use your hammer and then break it. Not manually, but they have all these balls, they just drop it and break it. Okay, but anyway, so that's another new item. Okay, everything else we covered. And then steel versus FRP. We already talked mentioned this many times. Linear elastic behavior all the way to failure, which is a problem. Okay, it's quite likely that deflections will govern your design. Deflections, crack widths are not a problem, but still, serviceability limit state is likely to govern your design, which is a problem. Okay, FRP have lower creep rupture than steel. This is going to be a bigger problem because I designed many structural elements using FRP bars, and we always get stuck here, creep rupture. If you are trying to satisfy the creep rupture requirements given in ACI, we will be in big trouble. Like you cannot design many of the structural elements like retaining walls because there's always sustained load, right? So that will cause creep rupture. So that kind of stuff, it is very hard to design. All that you have to do is add more FRP bars. So if you add more FRP bars to bring down the stress in the FRP bar, you are losing the benefit of high strength. So it's really, if you ask me what is the most critical design item in any structural design, practical design, creep rupture is a problem. Everything else you can handle other than creep rupture. Fire is a problem, high elevated temperatures. Okay, so Other items we already discussed, so I'm just moving on. Um, some applications, FRP bars are advantages. We talked about that. Yeah. So, yes.
Great defect of concrete is considered only pre-stress concrete, but for normal unstressed pre-stress concrete is not considered great.
So we are considering deflection and shrinkage.
So in deflections we are
That's right.
considering, but usually for the pre-stress concrete we give
We are
more importance.
considering based on the creep coefficient, we are calculating the creep deflection and shrinkage deflection, and then we are considering the deflection. What are the safety criteria? Short term and long term both, as per IS 456 and as well as ACL. In every code.
Yeah, okay. What you are talking about is creep in concrete. This creep rupture refers to creep rupture condition in bars, FRP bars. So tomorrow I will present that creep, maybe not tomorrow, maybe day after tomorrow, I will present creep rupture design, where you will see that we can only allow up to certain amount of stress under sustained loads. So that's a problem. Whereas steel, you don't have to care about sustained load acting on steel.
Except for
Re-
temperature.
Yeah, but generally you worry more, in case of pre-stress concrete, you worry more about creep in concrete and relaxation in steel. Okay, those are the two things you consider. Whereas in case of FRP reinforced concrete beams, you consider creep rupture in FRP bars. We are not looking at creep of the concrete, we are looking at the creep rupture of the bars. So it becomes very, it normally governs the design. Okay? Yeah, it is a big problem. I know that because I designed a lot of water tanks and retaining walls. Very difficult. To the extent that sometimes you have to just abandon it. You say, we cannot, because it becomes so expensive. If you are using 10 times